So in this video, we're going to look at how to calculate the compound and simple interest for any values that are given to us. And we look at the different types of questions that they could possibly ask. We're also going to look at how to calculate the depreciation of an item. And in order for us to have a look at this, what we know is that in the examination, they will give us a formula. Okay, so whether it's on the non-calculator or the calculator paper, you will get the formula for compound interest only. The formula looks something like this. And if you notice, on compound interest, they write the formula as follows. So the total occurred is equal to P, where P is the principal amount and R is the interest rate over a given period, and N is the number of times the interest is compounded. A lot of teachers sometimes recommend that the N kind of stands for the number of years or the number of months, for example. However, what we're going to do is I'm just going to kind of change the formula slightly a little with just the letters. Although you need to learn it like this, I like to replace the P with an A. And the A represents amount, as in the amount invested. Total occurred, I'll just call it T for now, as in total. So the formula looks just a little bit more simpler, but you will get this in the exam. So one of the things I like to focus on, if I get rid of this, there we go, and I'll get rid of the formula sheet, is the fact that the T is now equal to A multiplied by open bracket 1. I'm going to put a plus and I'm going to put a minus here, R over 100 to the power of N. Now, as we said earlier, compound means when you are reinvesting the amount. And because you are reinvesting the amount over a certain period of time, okay, and therefore we will have additional, say for example, money in the account, we will be using the plus sign, okay? So we're making interest. If, for example, we are at a loss, so an item is depreciating, and generally items which lose value or depreciate are things like a van or a car or a mobile phone. So over time, its value does decrease or drop. Whereas an item such as, for example, if you've got money in an account, you will get interest on it. If you have a house, okay, over time as well, okay, it holds its value, therefore it will increase. Similar things like gold or diamonds. But what we're going to do is, we have the plus, as we said, if it is compound interest, and I will introduce simple interest as well. We can use the simple interest here, but I'll go through it simply with you. We have the minus, so we have to pick one of them depending on how the question looks. Now for me, what the most important item in the entire thing is the entire bracket, which I'm going to highlight in blue and I'm going to pull out here. So let's work on the plus at the moment. So 1 plus R over 100 in brackets. This is the most important thing in the entire formula. The reason why this is the most important thing is because the bracket represents the multiplier. So therefore, if for example, I was to say, and as we know, the word multiplier sounds like multiply. If I was to say that we are at an increase of 10%, we can replace the R with 10. So we've got 1 plus 10 over 100. Now, as you know, 10 over 100 is 0.1. So we end up with 1 plus 0.1. And if I add 1 plus 0.1, I get 1.1. This number here is called the multiplier. I'm also going to show you something else on this, which is really important to kind of figure, is I'm going to stick with 1 plus R over 100. If my multiplier works out to be, for example, 1.38, and if I multiply 1.38 by 100, okay, the famous number, I get 138. What this 138 means is that your original amount is 100%, okay, this will always stay the same, and if I add 38% on top, I end up with 138, which means there's been an increase of 38%. Let's take another number instead. What if the entire bracket, so 1 plus r over 100, there we go, and I got an answer of 1.273. So if I multiply this multiplier by 100, I get 127.3, which means again it's 100% plus 27.3% to make this number up here. So therefore there has been an increase, okay, of 27.3%. Some of the more trickier ones that they like to ask is, for example, 1.045. So it gets a bit more interesting here. Again, if you multiply by 100, you get 104.5, which means it's made up of 100 plus 4.5. So therefore, 100% plus 4.5% is made up of 4.5% increase. So whenever you see a multiplier, you are expected to know what the percentage is. If I gave you one that's 1.036, let's do 5, there we go. Again, just by looking at this, multiply it by 100, so move the decimal 2 places to the right, so it makes 3.65. Therefore, there is a 3.65% increase. So the bracket is really important for you to understand, okay, what the percentage is, the rate is. And we'll come to the multiplier in a second, especially with questions without using a calculator. All right, let's have a look at the first question. Perry invests £25,000. So the A is equal to 25,000 for 3 years. So N is equal to 3. And she gets 2.7% per annum. Annum means per year. So therefore, the R is equal to 2.7. You don't need to put the percentage sign in. And the question is, be careful, they've put this in bold. Calculate the total amount of interest made after 3 years. So let's use the formula first. So T equals the amount originally invested multiplied by open bracket 1 plus R over 100 close bracket to the power of N. Therefore, T equals, ensure you keep the T there, the amount originally invested, which is 25,000, times open bracket 1 plus the R rate is 2.7%, so 2.7 over 100. Please ensure that the fraction is not connected to the 1. Close bracket, and that would be to the power of 3 or the cube. Take your calculator for me right now. Plug the numbers in and let's see what answer you get. Remember, if you get a decimal, then it should be always to 2 decimal places. The reason why it stays to 2 decimal places is because it is to do with money. So have a go at that. So I managed to get an answer of T is equal to 27,080.16708, and because this is money, it is to do with 2 decimal places, so we underline the first 2 numbers after the decimal point and circle the third number. We don't need the rest. So because the 7 is above 5, is 5 or above, the 16 therefore is rounded up. So therefore T is equal to 27,080. So £27,080 and 17 pence. Be careful though with this kind of question, because this is the amount after 3 years, okay? Because the amount has been reinvested, okay, over the number of years, but they're asking for the amount of interest. So in order to find out how much interest you've made, okay, you need to see what the original amount you invested, which is 25,000, and what you've got at the bank at the end of the 3 years. When you've got those 2 amounts, what you now need to do is 27,080 0, don't forget the pennies, 0.17, and you take it away from 25,000 to see how much money you've actually made in between. So if you do that on the calculator, you should have got an answer of, I'll put it in yellow up here, £2,080 and 17 pence. So that is the amount of interest made. So have a go at this question. Don't forget, first write the formula, don't plug the numbers in straight away. Then identify what number represents which letter in your formula, substitute, and then answer. And if your answer is more than 2 decimal places, write the digits out and then underline the first 2 numbers and circle the third number. And I'll put up the answer in a second. So pause the video now. Here's what you should have got if you've substituted it. The answer after the decimal point should be to 2 decimal places because we're dealing with money. So therefore we circle the third number and ignore the rest. The 2 that we've circled is a number that's below 5. So the 77 stays the same. So therefore the answer is £2,813 and 77 pence. Okay, that's your final answer. The reason why we don't have to take away this now from the original amount at the beginning is because they're not asking how much interest has been made. So you've got to read the question carefully. It just says, how much money does Leanne have at the end of 4 years? Here's another question. Pause the video now and I'll put up the answer in a few seconds. I've put the answer up this time and rounded it to 2 decimal places. Just check if you're correct. What's a really nice thing sometimes to do as well is see the bracket, as I told you, which produces the multiplier. If you didn't go straight for the answer, you can still write the next line here as t equals 9,500 multiplied by 1.018 to the power of 5. So you can keep the multiplier in there by just working out the bracket. The bracket is very, very important for you to work out because in the examination paper, okay, they do enjoy seeing the multiplier and you can get a mark for that. So sometimes they don't give a mark just for writing this only. It's great that you substitute the numbers, but they're interested in what is the multiplier. So now that we've practiced how to actually use the formula, what I would like you to do in the next set of questions, or the different type of questions we'll tackle, is see if you can work out what the multiplier is. So let's do a big push on the multiplier this time, and from the multiplier you should be able to look at the interest rate for the next part. So this question doesn't involve interest, but this time look at the key word here, depreciates, when there's a fall in value. So we're going to use the same formula again. T equals amount multiplied by, open bracket, 1, but because it depreciates, the amount drops. So it's 1 minus the rate over 100, close brackets, to the power of n. Now, a good thing about this question, why it's challenging, is because it says Nick bought a new car. Each year the car depreciates by 12%, so R is equal to 12. Work out the number of years, so we need to work out the number of years so that for the car to half its value. So you can half it exactly on its value, or it can just drop below that half. But you can't be over that half value. Here's the other problem though. They don't tell us what the actual car was, the original value. So guess what the good news is? You can give it a value of your choice. I'm going to just give it a value, nice simple value of £1,000. Okay, so a nice cheap car. So in order for that to be 1,000, okay, for the original amount to be 1,000, the final total should be at least half its value. So around near 500 or below. So what you're going to do for me is you're going to start with £1,000 multiplied by 1. Don't forget it's minus because it depreciates. 12 over 100, close bracket, to the power of 1 year. So get an answer and see whether the value is £500 or less. Or less. If it's not, guess what you now need to do? You need to redo it again. So you're going to do 1,000 multiplied by 1 minus 12 over 100, but this time you're going to try 2 years. If that's not the case, then you try 3 years, and then 4 years, Okay, so I want you to have a go at this. I'm going to put up for the first couple of years, year 1, year 2, and then I'll leave it. Then I'll pause the video, and then I'll give you the opportunity, okay, to try and see how many years and whether it matches with my answer. So for the first one, I've got £880. So we haven't really hit 500. 2 years is equal to £774.4. Please be careful in the calculator. If it's 0.4, do not forget it's 2 decimal places, so fill it with a 0, so it's 40p. I want you to try 3 years, 4 years, 5 years, whatever it takes, move up until you hit 500. I'm going to put the answer up, and let's see if you've got the answer that's the same as mine. Off you go. So after 6 years, I've managed to now just drop below the halfway value to get to £464.40. If you did have 5 years, then it would have been above 500. So you actually haven't hit the halfway mark. So it needs to be 6 years. Okay, so have a look at this question. Jesse invests £8,000 for n years in a savings account. To find the value of V, so they've, instead of using T for total, they've used V. So we have to just remember that V represents RT as in total, because they've counted V for value. After n years, she uses the formula. It is a similar formula as T equals amount multiplied by 1 plus the interest rate over 100 to the power of n. Now let's just break it down. You can see that the V in the front represents the total at the end. The 8,000 after the equals represents the amount originally invested. The 1.025, now we did this right at the start of the session. We've said that that multiplier is this entire bracket here. Therefore, if they've just given us a number, which is the multiplier, we should be able to convert it back into the rate to find out, okay, what the percentage is. So what was the rule that we said? Because that's the first question. Write down the annual rate of interest. Okay, that's the value of R. So let's take this 1.025 that they've got. So 1.025, we times it by 100, which then gives us 102.5, which is made up of basically 100% plus 2.5%. So yeah, you've guessed it right. It is the number after the 100. That's the increase. So therefore, the rate is 2.5%. The next question states, as we know what the percentage is, I mean, we don't have to use that because we've got the entire multiplier, it's done for us. But the next part of the question states, find the total amount of interest. Now, we did this right at the beginning, where to work out the total amount of interest, it is the final amount that we've got, take away the original amount invested, and that gives us the total amount of interest. I'll let you pause the video, have a go at that yourself, and see if your answer matches mine. So you should have got in the bank at the end £8,615.13. Therefore, the total amount of interest in 3 years is £8,615.13. Please be careful with the pennies. Take away the original amount invested, £8,000, and you should get an answer of £615.13. So here's a very popular question in GCSE exams where you might have seen, where they don't just give you one rate, they give you a range of rates. Sometimes they normally give you 1 or 2. And then in this case, we'll go straight for the jugular on this one. They've given you 3 this time. So think about the formula, okay? Work out the value of the house at the end of 3 years. So therefore, T equals, okay, amount multiplied by, actually, what I'll do is I'll put this up here. So T equals amount multiplied by, open bracket, 1 plus, because it's increased here twice, okay? So 1 plus the rate over 100 to the power of n, but I'll also put T equals amount times 1 minus the rate over 100 to the power of n. The reason why I've put minus, because as you can see, it also drops by value as well, which we'll come to in a second. So first things first that we're going to do is we're going to look at the first 3%. So therefore, the total is equal to 350,000 multiplied by, open bracket, 1 plus 3 over 100. And because it's the first year, okay, only the first year, we do it to the power of 1. Well, if it's to the power of 1, you don't need to really put that in there. But if you want to, just to keep your peace of mind that it is 1 year, more than happy to do that. Okay, and you should have got an answer of £360,500. So now that we've got that, guess what we do with this? Now we're going to invest this in our second year. So we'll do the formula again, T equals, but this time our new amount invested, okay, is the amount that we received at the end of the first year. So 360,500 multiplied by 1 plus, this time, I'll do this in green, there's an increase of 2%. So it's 2 over 100. Now, students sometimes think that because it's in the second year, they have to be to the power of 2. But that's not true. The first line that we did here, the working out, that was year 1. The second line here is now year 2. So this would be to another 1 year. Because you've already done the first year. This is now your second year. So if you put that on the calculator, you get an answer of 367710. You should be checking it in between. Now the third one, okay, our third year is T is equal to, now we're going to use this output as the new input. So 367710 multiplied by 1 minus this time, because now we're depreciating it. So minus, it's now 5%. So it's 5 over 100. And this is another 1 more year. Do that on the calculator and see what you get. And you should have got an answer of 349,324.5 on the calculator. You would have lost a mark because you can't have 0.5 of a pounds. So therefore, because that's what the calculator shows, you must ensure that there is the answer to 2 decimal places. So it's 50p. So your answer is 349,324.50. Please make a note of that answer, because what I'm going to show you next, okay, is a much better way of doing it as well. If you're struggling in the exam, you have to show this line by line. So your output becomes your new input. Your then output of the second one becomes your new input for the third one. And that's your 3 years. So I'm going to redo this question one more time, but watch how I do it this time. So what I'm going to do for this question, I'm just going to focus on the 3 percentages, the 3 rates, and I'm going to use multipliers. So the first one here says an increase of 3%. Now, if we turn that to a multiplier, remember the multiplier formula? So it's 1 plus r over 100. So I'm only interested in this. So therefore, the first one becomes 1 plus 3 over 100. Okay, and if you do that, you should have got an answer of 1.03. If you do the second one, you have 1 plus 2 over 100, and you should have got an answer of 1.02. Hopefully you can see the pattern as well, okay, how you turn this sum with a rate of 3 to 1.03, because if I times this 1.03 by 100, okay, it shows me that I've got 3% above 100. Same thing with the second. The third one, please be careful, it says depreciate, so it's 1 minus 5 over 100. And if you do that on the calculator, you should get, because it's a takeaway, it should be below 1, so you should get 0.95. So you end up with, which is interesting, 1 multiplier, 2 multiplier, 3 multipliers. Okay, and this is why I told you right at the beginning of the session why multipliers is important. What if I've got here more than 1 multiplier? In this case, I've got 3. So I've got 1.03, I've got 1.02, and I've got 0.95. If I now multiply my multipliers, so do that on the calculator for me, I get, and I've done this in yellow, I get, if I multiply the 3 multipliers, I get a super multiplier, which is put all 3 multipliers in one go as one super multiplier. So I'm going to use that super multiplier now, and I'm going to multiply £350,000 multiplied by my super multiplier. If you do that on the calculator for me now, please, you get the same answer that we got when we did it the manual way, okay? And don't forget the 0 at the end. So we get £349,324 and 50 pence, all because we focused on the multiplier. Similarly with this question, okay, I always write the formula out. So T equals amount times 1 take away R over 100 to the power of n. The reason why I'm just sticking with minus is because both parts have got the words depreciate. So there's no actual increase in this. In order for us to do that, please be careful with this. It says Greg bought a new car for £18,000. In the first year, the value depreciates by 30%. In the second and the third year, okay, so second and above, beyond that, okay, it depreciates by 14%. Again, you can do the following: £18,000 multiplied by 1 minus 30 over 100, and that's for the first year, and you get an amount. Please work that out. You can then take that amount and put it in again. So that amount is then multiplied by 1 minus 14 over 100. But this time, because we want to work out the value of the car after 3 years, okay, so second year and the third year value. So now here I've got in this line under the 14%, 2 years. So that's the second and the third year. It is to the power of 2. Therefore, the 1 year plus the 2 year makes up the 3 years. You then put this in the calculator and you should get an answer. Pause the video now and see what answer you've got. So the final answer that you should have got was, the answer before you should have got was 12,600. You put it in now for the year 2 and 3, so at 14% for the next 2 years. And this is what you should have got for your final answer, £9,318 and 96 pence. What I would like you to do though, I want to just clear this. What I would like you to do is, I would like you to find out what the super multiplier is. So pause the video now, have a go, and see whether your super multiplier matches with my one, and then we'll multiply by 18,000 to see if we get the same answer. So when I'm doing this, the first one that I've got is at 30% for the first year. Okay, so for the first year only. So if I put that as a multiplier, I get 0.7. For the next one, 14%. Again, I've put it as a multiplier, but this time it has to be squared because it is for year 2 and 3. So that's so important. And you should get 0.7396. So what do I do with the multiplier and my second multiplier? I multiply the multipliers, and therefore I'll get a super multiplier. So therefore I end up with £18,000 for the car multiplied by, so 0.7 times 0.7396. So 18,000 times the super multiplier, which is 0.517772, and I should get an answer of 9318.96. The final question I want to have a look at does involve simple interest. It says Alice is going to invest some money for 5 years. She can choose from 2 options. Always ensure that you split the page up in half. So you've got investment A and investment B. Investment A is a nice compound interest question again. So T is equal to the amount multiplied by 1 plus the rate over 100 to the power of n. Therefore, T is equal to the amount she's not actually mentioned. So therefore, what do you do when there's no amount mentioned? You create the amount of your choice. So I'm going to just put in, say, £1,000. That's always the best one to put in. So let's put £1,000 multiplied by 1 plus the interest is at 2.7 over 100 to the power of, and they've said for 5 years. So let's put it to the power of 5, and therefore T is equal to £1,142.49. So the interest made is £142.49. Now the rule for simple interest is you never use compound interest. You use the formula, but you only do it for 1 year. So therefore, when you do it for 1 year, you get an answer of £1,028. Therefore, the interest that's made is £28 for 1 year. What you do with simple interest, okay, compared to compound, is that the interest that you have worked for 1 year, which you're supposed to, is then multiplied by the number of years that you've got. So the interest stays the same every year. You don't reinvest the interest as well to make more money. So we do £28 times 5 years, and we get £140 interest over 5 years, considering that 28 stays the same. So which is the better answer? On compound, you made £142.49 in interest, whereas in simple, where it stays the same, the interest every year, so only work out the first year, don't put it to the power of 5, okay, and multiply it there, is you get £140. So investment A is the better investment.